I'm here to assist you with all your test equipment needs, from multimeters and test weights to patient simulators and x-ray analyzers. If you need guidance or you have any questions, please don't hesitate to write me at jbarber@bcgroupinternational.com.
What's going on, everyone? Welcome back to Better Biomed. Today we're going to talk about drilling. And the reason we're going to talk about drilling is because it's the one thing that you don't have to do very often, but when you do, it's usually a make or break moment. And a lot of people do it wrong. So we're going to go over drill bits, different types of drill bits, different types of drills, and then we're going to go ahead and we're going to talk about drilling different materials so that you do it properly and you don't destroy your tooling, which is very important because tools are generally meant for more than one use. That definitely includes drill bits. So let's go ahead and move this camera around. We'll bring you in nice and close so we can introduce you to the world of drill bits and drilling.
Folks, I've gathered up a collection of drill bits here to give you a little bit of an idea of what you might find in most case scenarios in shops. And I want to first off to let you know that there's metric and standard drill bits, but there's also different types of materials that not only make the core, but the coatings. Yeah, there's different coatings. So the first type of drill bit that we're going to cover, now these here are all regular twist drill bits. They're called twist drills and is what we normally call drill bits, but all these are technically drill bits. So let's specify these are twist drills. Now these ones here are standard 2 flutes. The flutes are the grooves that are cut down the side. So there's only 2 flutes on these ones. That's used for removing material and it aids with the cooling of the drill bit. Very important feature. Now these ones here are all technically high-speed steel. HSS is how they're going to be indicated on the shank. But high-speed steel has other features. It's more durable than standard steel. It's meant for drilling a lot of things, but its hardness is meh. So what they do to extend the life of high-speed steel is they give it some different coatings. You can see right here, this large drill bit, it's called black oxide. Hence, the dark color on the outside. This one here is also black oxide. Now these ones here are titanium or titanium nitride coated. You see, when you see drill bits and they say titanium, it's not a titanium drill bit, it's actually the coating of high-speed steel. See that? So these ones here are all high-speed steel. These ones here have different coatings. Now black oxide being one of the hardest coatings, this guy uses for cutting various types of steel. But when you need to cut something even harder, like stainless steel, something that you're going to find very commonly in medical environments, that's when you turn to cobalt. Now cobalt, it's a very dense material. You can feel it. And it has that weird yellowish brown color. You can see that. It's very definite. And you can always compare the shank. It's very definite. It's different. It feels different in the hand because it's heavier. Mind you, it's also very, very sharp. Cobalt maintains its sharpness longer than the other ones, and it actually is a little bit expensive compared to some of these other ones, usually. Why don't we all just use cobalt for everything? Well, because while you increase the hardness, you also increase the brittleness. So sometimes you don't want that drill bit to shatter and get stuck in a hole. And you know, if it shatters and gets stuck in a hole and it's cobalt, you have some problems. If it's high-speed steel, there are several methods of getting high-speed steel out of a core material when it gets stuck and sheared off. Cobalt, it's extremely nice. It's good for a drill press. I probably wouldn't use cobalt for a hand drill because, you know, they can be a little bit fragile, but they're extremely sharp. I have a couple other examples here. We have something called step drills. Now we have metric and standard step drills, and what that is every single stage right here is technically a different drill bit. These are very good when you have a large hole that you're trying to drill in a softer material, and you don't want to go through and do a pilot hole, multiple pilots to get up to this diameter. We'll talk about pilots later. But you can see I got 2 different types. I've got the straight flute, and then I've got the twist flute. See that? Now my favorite is going to be the twist flutes. These ones right here. These are absolute champs. Got these ones from Harbor Freight. These ones, if you can't tell, I've cut a lot of different stuff with them, various hardnesses. The straight flutes, they do work. They usually show extra wear and tear pretty quickly. They still work, but these are step drills. Mind you, I would not use a step drill to cut hard materials. It's not a good solution. They don't break. That's a good thing about them. However, the problem is that they're not really good at removing material. Twist drills are much better at removing material out of a hole than these guys. The next type of drill bit that you might see is called a masonry bit. And while this is a horrible example, because you can see the end of this masonry bit is all chewed up because it just ate its share of ceramic. That's right, guys, ceramic. One of the hardest materials known to man. We actually have drill bits that are designed to be able to eat through them. Now, how do you do that? We do that with a hammer drill. And the hammer drill is a special type of drill that's got a stage or a setting on it where it creates vibration. And that vibration impacts at the tip hundreds of times a second. And all you hear is a bzzz. And that impacting creates and pulverizes tiny little bits of the drill material, the material that you're trying to drill out, and then the flutes move that material out of the hole. And as you can see, the carbide tips, now we didn't talk about carbide because it's a whole special animal. However, there are little carbides that are soldered to the end of this drill bit, and it can handle heat and it can handle really hard materials really well. However, you can see that ceramic is just so tough that it eventually destroys bits. It is what it is, guys. I've got a spade bit right here. These are normally used for woodworking. They're fast, but they work best with drilling through soft materials like pine. And then I've got some special types of drill bits. And I've got a bunch of these ones. This is a drill tap. You can see it drills here, and then it taps here, and then it clears down here and chamfers the hole with the profile down at the end. Now this one here is only used in select case scenarios and is not preferable for drilling and tapping holes. For that, we use very special drills. Now this right here is a drill and tap kit. You can find them in kit or you can buy them separately. But in order to tap a hole to the accurate dimensions, you have to have a very special drill. Now, normal dimensions of drill bits are not acceptable for most precision taps. For loose tapping, no problem. You can come close. But for precision tapping, you're going to have a special size drill bit. So instead of being like 8 millimeters, you'll have 8.3 millimeters, and that's the cross section. And 8.3 millimeters, if you can imagine it, is not pretty common, okay? So these are very special, and this one here is a 5.0 high-speed steel. It's stamped down on the shank. And this one here is a number 6, see? So this is the one that comes with the kit, and this number 5 right here is, this one is a close approximate. So I can have a really tight hole, or I can have a precision hole. So, and then this is a plug tap, and this is an M6 by 1.0 plug tap. So these all get bundled together in my kits so that when I need to make this specific type of tap, which threads a hole so that you can put a fastener through it, it all comes in one kit. And yes, I do keep them like that. They're not moving around, they're not vibrating, so it's okay. Normally you don't want to stack drill bits next to each other because what they'll do is they will wear on each other, especially if they're in like a toolbox. They'll be wearing on each other and they will destroy each other's hardness. So we got high-speed steel, we've got different coatings, we've got different core materials like cobalt, and we talked about carbide. Carbide is extremely fragile, although it can handle a lot of heat, a heck of a lot of heat. And cobalt is really nice for drilling through harder materials like harder steel. We've got different types of taps, And we've got step drill bits. Now, I'm definitely forgetting some. Guys, let's talk about cutting holes. Big holes. So this one right here, this is a hole saw. And this one here can be very, very dangerous. Matter of fact, it's got these high-speed steel points, which are extremely sharp. And if you can imagine the mass on this guy, if you put this in a drill and you start slinging it around at 3,000 RPMs, this guy here is just waiting to take some fingers off. So that's where we're going to talk about speeds, okay? We're going to talk about drilling speeds, because if you get into specialty items like these hole saws, like this Milwaukee set that I've got here, which does in fact have high-speed drills down here, and then it's got these barrels that screw on, and this is the actual hole diameter that you're trying to cut. Now these ones here will often have bimetallic, which means they'll have two different types of metals that are that comprise the teeth, and they come in a variety of different dimensions. You see that? So these are hole saws, and since we're going up in diameter, let's go ahead and let's go over to the drill, and I'll show you in person what I'm talking about, because this is where people mess up things a lot, is the speeds and the feeds of the drill. Let's do it.
All right, guys, I'm over here at the drill press, and first things first, you can see I'm wearing my protective gear, my eyewear, and my clothing is buttoned up. You can see I have no loose clothing, because the last thing you want around a rotary tool is anything loose. On top of that, I have mixed feelings about gloves, guys, because believe it or not, I have had gloves. I don't know if it's this exact pair. Yep, it has this exact pair. Look at that. God, how many years have I had these? Have saved my finger. I was using a large rotary cutter like this guy here, and there ran into an issue, and the cutter went over to where my hand was. I was holding it off to the side, but the rotary cutter got loose or something, and it came over and it struck the glove, and I was able to get my hand away in time. I understand. Gloves are a huge no-no around rotary tools, folks, because if anything gets caught on that glove, your hand will wind around and you are completely helpless, right? It will break your entire hand, maybe your arm, and you'll get sucked into the machine. Whereas if something cuts your skin, I can touch drill bits while they're full speed, and I might burn or cut my fingertips, but my hand will not wrap around it per se. It would take a lot of grip and maybe skin to get caught in order for that to happen. It's not going to break my entire wrist. I'm just going to lose some skin. So folks, don't wear gloves when you're working around rotary tools. Now this is a drill press, and on typical drill press, the speeds are maintained. You see that there's a little chart right there, by changing the pulleys. In order to change the pulleys, we have to loosen some fasteners, and then we disengage, and that creates slack here between the motor and the main pulley, and then we change the pulley configuration. You see the little chart right here. Now there are different types of transmissions on these guys. This here is more like an idler pulley. It doesn't actually serve any drive functions. It's just a intermediate between the main drive, which is the motor shaft, and this right here is the output shaft, which comes down here to your chuck. So that is a drill press. Now drill press, if you can do any type of work on a drill press, do it there, because it's just going to be more accurate and you can create more downforce than with a traditional hand drill. Now on the notes of traditional hand drills, this is also a hammer drill. You can see it. I know you guys that are going to say, oh, it's not a real hammer drill, yada yada. Trust me, I have drilled a lot of stuff with this guy right here. You can tell it's had a rough life, but a hammer drill is a clutch option. You see, I rotated the clutch right there in the hammer position. And when it creates a little bit of resistance in here, there's a little bit of reciprocation, and that is what impacts against the masonry and allows you to chip out fine masonry with a bit, a not very sharp bit at that. So hammer drill, they're good. I recommend getting a really nice chuck on a drill, guys, because there's nothing worse than a tool with a bad chuck, right? So this is a grip chuck. It's a style of Jacob's chuck, 3-jaw, and drills are rated in the size that the chuck can take. Now this is a 1/2-inch drill, so it can take a 1/2-inch drill bit. You see that? There are 3/8 drills, and I believe there's 1/4-inch drills as well. This is a 1/2-inch. And to be honest, modern day drills, I don't see the need for having a 3/8 drill anymore, because there are some really compact 1/2-inch drills. So when you hear like 1/2-inch or 3/8 drill, that's what they're talking about right here, is the diameter of the opening for the chuck. So anyway, folks, this here is a brushless design, and that means that it does not have motor brushes, but it also means that it is digitally controlling the speed. So later on, we're going to talk about speeds. You have to have really good trigger control. You can see right here, I'm at its lowest speed. When you're hand drilling, you have to take notice of your work, take notice of the drill bit, and also the angle that you're approaching the work, and you have to change your speed accordingly. Most people go full nut when they're cutting stuff, and that's how they end up smoking drill bits, because, as I said earlier, the enemy of drill bits is heat. The enemy of all metal is heat, really. And what creates heat? A lot of friction, and that's what you're going to get. So if you get a drill bit that starts to get hot, well, it's going to create heat, it's going to temper, and it's going to lose its cutting edge faster and faster and faster until you smoke the bit. Now, there are ways that we can prevent that. One way is adding cutting oil. Now, I understand this is WD-40. All you cutting guys out there, they're like, oh, don't be using that. You can use WD-40. It's not the best. I generally use a higher viscosity type of oil, and they even sell real cutting oil. I suggest keeping something like that near your drill press, because as we're going to see, we're going to cut a variety of different materials, and it is going to change your life dramatically, and it's going to improve the cut along with the life of the drill bit. So let's go ahead and let's show you what I'm talking about.
All right, folks, I have a collection of different materials down here, and these are going to be very typical things that you're going to cut either in a medical environment or at your home. So this is a standard piece of really soft wood. Now, I believe this one's poplar, but poplar, it fragments quite a bit. When you're drilling wood, it's always best to have 2 pieces, because you put one piece below the first one, so when you drill through the piece that you want, it doesn't splinter. So you always use 2 pieces when you're drilling through wood. Now, when you're drilling through harder materials like this composite right here, this composite is definitely something that you're going to find in a medical environment. In fact, this one here is to the top of a surgical table. Now, as I said earlier, friction destroys drill bits, but friction also can destroy your workpiece, because things like this guy right here, this composite, it is a very hard material. Very hard. Very hard material. But it is also technically soft when compared to metals. And it wants to splinter because it's a composite. It's created by compression. So when you drill through it, always make sure that you have a secondary material underneath it so it doesn't splinter. I'll give a demonstration of that. I have a piece of aluminum here. Now this is just a standard bar stock aluminum. This is very typical to what, if you're making a jig or something, the type of material that you're going to be using. Aluminum is a funny material because unlike some other materials, aluminum has the ability to get gummy. So as you step up to harder and harder materials, usually you want to decrease your speeds. So that means in the order of hardness, I would put them like this. Now this final piece over here, I do believe that this is cold rolled steel. It could be a harder steel because this bracket actually goes to a garage door opener. But guess we're going to find that out when we go to drill it here in just a moment. But this bracket right here, it's probably going to be magnitudes harder than the aluminum. So I'm going to place it over here at the far side. So
We got poplar, which is just regular wood. We've got carbon composites. We've got aluminum. And then we have steel. So let's go ahead and let's talk about drilling your first holes. So when you go to drill a hole, the first thing you should do is mark where the hole is going to be. Now, this right here, I have a scribe, and a scribe usually has a piece of carbide in the tip, and it's used for drawing lines like this. So when you scribe in a material, a measurement. So normally, let's say I want to cut 1 inch. So I mark my initial line, measure out 1 inch, make an etch where the 1 inch is. And now, let's say I want to make my cut right there. One of the things you're going to find is that when you go to drill, the drill bit wants to walk, which means you start drilling here, and because of rotation and friction, it navigates off to an unpredictable location. So what we do is we have these things called center punch. Now this is an automatic center punch. There's another type that use a hammer, but with the automatic center punches, you place it exactly where you want, which there's my 2 scribed lines, and you press down, and you hear that little pop. What that does is it creates a hole or a little divot. Now that divot doesn't seem like it's very important. However, it changes the entire game when it comes to drilling. Now I recommend doing this on wood. I recommend on aluminum. Every time I go to drill a precision hole, I'm going to use a center punch. That way there, the drill bit stays exactly where I want it. Now after we get the center punch hole drilled or indented, then what we're going to do is we're going to create a pilot. Now a pilot is a small hole that's going to guide your larger drill bit. So in other words, imagine if I wanted to drill this 1/2 inch hole right here, even though I center punched it, the chance of that migrating off is still kind of high, okay? And if anything, it's going to be much more stress on the drill bit, the drill, the material, everything's going to be much more stressed than if you drill a small hole, which is going to guide a larger hole. So we're going to go ahead and do that right now. So this is going to be my pilot hole. I don't necessarily care what diameter it is. Now notice I'm drilling through a soft material, so the drill is actually moving at a pretty fast speed. So I'm going to start the drill bit with a little bit of a kiss. That kiss aligns it to the hole that I marked. And then I press down and drill through. Luckily, I went slow enough where it didn't break out and splinter out as much as I was expecting it to. Normally, you want to use a second piece of waste material underneath your intended hole. That way there it doesn't splinter out. This is a small drill bit. It was rotating kind of fast, and I went pretty slow on the feed, so we're good. So that is my pilot hole. Next, I'm going to step it up. Now, a rule of thumb, especially with harder materials, is to double the diameter. So even though I have a pilot there, still going up to this size is probably not exceptional. So I'm going to step it up. The rule is going to be to step it up to the next size, which is double your first hole. I didn't change the speed of the drill because we're not there yet. A little bit of a kiss that aligns my material. And we cut through. Man, those are sharp drill bits. They're cutting through beautifully. Look at this. This is the backside. I did get a little bit of blowout. Would not happen if I had a second material underneath it. So this hole here, it's okay. But I want to go up to a 1/2 inch. So we're just not there yet. Next, I'm going to go ahead and step it up. Again, about double the size. Now, mind you, there's 3 different grooves cut into the shank of this drill bit. So you kind of have to shake it, make sure it's aligned with the jaws. And then crank it down. Just check to make sure I'm not going to impact. A little bit of kiss, and drive it through. Now notice what just happened. Even though I have a pretty good grip on my material, it picked it up and it wanted to sling it around. That is going to happen, and it's going to happen pretty frequently. You just got to maintain your grip, get ready to drop your hand, and or use clamps on your material. Now for this demo, I'm going to go kind of quick, so I'm not going to use clamps. But what that does is when it grabs the material like that, it creates some rough spots and it makes it a less precise hole. However, I did not get a blowout, so that's a huge win. Now let's step it up. Let's go to a harder material. Now imagine if I were to try and cut with this. Matter of fact, let's do it. Let's try to cut right through. There's a lot of pressure because there's no pilot hole. A lot of pressure, which means there's going to be extra friction down here. And that drill bit almost definitely is walking, because not only can they walk side by side when you start the cut, but as you go through the material, the drill bit can actually cut at an angle to where the initial opening is, which means you could end up going at an angle because of differences in density. So that's why a pilot hole is so necessary, is because that guides the entire length of the cut. Notice I got some smoke. See that smoke coming up? That is not good, guys. That could be damaging my drill bit, and it could also be damaging my workpiece. Now this was a exceptional cut. Man, I got some sharp drill bits. I can see right here, I have a little bit of blowout on the opening. That is because I did not use a second piece of material underneath the first one. Now, when you're cutting a harder material, what you should do is decrease the speed of the drill. Okay, folks, I have it on A4. And that means when I turn this guy on, according to this, A4 is 280 RPMs. Believe it or not, that is way, way slower. That's actually going to be much better for getting a precision cut, but at the same time, slower for cutting harder materials. I cut a lot of metals and stuff, so my drill press gets set at slower speeds all the time anyway. There we go. Let's go ahead and close that guy. And let's set it up for our next cut. Alright folks, now that I have the speed set, I'm going to install my pilot drill bit, which is a smaller one. I believe this is, what, 3/16? It's going to be pretty small. However, normally when you decrease the diameter of the drill bit, you're going to increase the speed. This is okay, we're cutting into some harder materials. However, guys, I said before that we should mark out a spot where we're going to cut. That was my scribe. This is my automatic center punch. Mind you, I'm keeping my hand away from this bit because if you get close to the bit, it's going to be sharp. And that sharp bit is going to cut my skin. There we go. A couple love taps. I'm going to kind of set it right where my cut's going to be. I'm going to turn it on, and I'm going to give it a slight kiss. And move my workpiece a fraction of a millimeter. That's how I know that I'm right where I want it. And then a little divot is cut. Now, here is where some people differ on some of the stuff. Now, cutting oil is going to prevent a lot of the stuff from sticking to your drill bit, but at the same time, it's going to cool the drill bit and it's going to lubricate the cut. Some people do not like putting cutting oil on aluminum, but I'll tell you right now, from all the aluminum I've cut, which is a lot, it definitely decreases the amount of stick, and also decreasing the speed is going to decrease the amount of aluminum that sticks to your bit because it's not going to be molten. There's no need for that with aluminum. It cuts beautifully. Sweet. I'm going to bring it down. I put a dot of lubricant oil right in that hole. Kiss it a little bit. That aligns the workpiece. And notice how I'm slowly feeding it. And now I'm doing something called peck drilling. So I'm pulling it down and then lifting it up. peck drilling breaks the chips. You'll see I'll get a long chip on the cut, and when I lift up, it breaks off and it disappears. If I were to continue pressing down, I get this long and very dangerous piece of metal that's slinging around. It decreases the accuracy of the cut, and at the same time, it makes it very dangerous to cut for my hands right here. So this is called peck drilling. There we go. We're all the way through. And kill it. Clean off my work surface. You know, some people are like, oh, don't clean your work surface with your hands. Man, I've had so many metal slivers in my hands, I'm okay. So the reverse side of this, because I did not have a secondary material, you can see it is blown out. And that little piece right there can be cleared off using a larger drill bit. Just like that. Acts like a chamfer. Cleans it off. Now I have a flush surface to cut my next hole. Let's change out the small drill bit. Let's go to the next size, which that's going to be my final size on this one. Now mind you, this is aluminum, and with aluminum you can use almost any style drill bit because it's a soft metal. Now when we're going to steel, even hardened steel or spring steel, you cannot use high-speed steel. Or you can, you just got to be very careful. You are probably going to have some problems. So on this one here, I'm going to put a drizzle of oil down the length of the drill bit, and it's going to drip down to my workpiece. I'm going to bring it down. Give it a little kiss to center it. Now we start peck drilling. Now that we have our pilot hole drilled, we're removing a lot more material, and this is where the peck drilling really helps out. As you increase the diameter of your drill bit, it's less likely you're going to snap the drill bit off. However, with the smaller drill bits, if you don't peck drill and it binds up, it'll shear right off, maybe even cut your hand that's holding the workpiece. So as I get near the side, I hold it down firmly, slowly press through, and I have a beautiful cut on both sides. Look at that. Nice and sharp, nice and sharp. That's a good drill bit. All right, let's switch over and let's cut some steel. All right, folks, now we're going to go ahead and we're going to cut some steel. I'm going to start out just like I did the last time, especially for safety reasons. The harder the material, the more likely the drill bit is going to want to walk. So what I'm going to do is I'm going to create a good indent right here. That's going to be my starting point. I'm going to bring the drill press down, and I'm very lightly finding the center right there. For this one here, I'm going to put a drop of oil here. I'm going to lubricate the drill bit. And when you move to harder materials like steel, not only should you use a lubricant, but you also gotta slow down the drive speed and your feed speed. So notice I'm just kind of hanging my hand here, and I'm letting the drill bit do the work. I'm not really pressing on it. The chips are going to be much smaller and finer and sharper. So still using the peck drilling technique. This should be cold rolled steel, hopefully. If it's a harder steel, then you sometimes have to be careful to use a harder drill bit. There we go. And that hole is cut through. Now, I did get a little bit of blowout on the backside. So again, I'm going to take a drill bit, line it up, and do a chamfer with a drill bit. Mind you guys, I've done this for years. That's why I can do it like that. And we are going to step it up to the same size that I did the aluminum. All right, folks. Now, We're going to be removing a lot more material here. Again, we're lubricating the drill bit. I'm going to give it a slight kiss. Just right here. Right there. It lines it up. You can see how it's getting hot. If it gets hot, we reapply lube. Okay. We do not want that drill bit getting hot. So I always look for the smoke. You start seeing the smoke, you're starting to get hot. Those chips are coming out beautifully, folks. Look at that. All the way through. What a beautiful cut that made. So, folks, one of the things that you have to understand, we have metric, we have standard drill bits. There's drill bits that have different core materials, like high-speed steel or boron, but there's different coatings. We have titanium nitride, titanium oxide. We've got black oxide. And you have to understand that as you go to harder materials, you have to slow down your speeds and you have to lubricate the drill bit. As you get to harder and harder materials, you have to be more and more careful, because if you try to force feed it, it's going to snap your drill bit, maybe into your workpiece, and it's going to absolutely ruin your day. If you're drilling stainless steel, which many of you who are in medical are going to be dealing with stainless steel, I highly recommend that you use lots of lubricant, use really hard drill bits that are meant for drilling steel, and look it up, because it's going to be a huge factor. And don't destroy the workpiece. If you're ever in an uncomfortable position, you think it's above your skill, look to somebody else. Don't do it yourself, because you could ruin something and you could get yourself hurt very easily. So, folks, there we have it. It's a quick rundown on drilling. I know, folks, there's a lot in this topic, and I just want you to be aware that there's a lot of intricacies. It is like an art, and as you get into metals particularly, you have to be more and more careful, because metals can be gummy like aluminum, or they could be fragile, and the harder the material, the harder the drill bit has to be. Thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.